when the pressure can increase the boiling point, is the inverse true? So let me ask you guys this way. Pressure, we know that it can increase the boiling point, right? With increase in pressure, we see the boiling point increasing. Now, is the inverse true? Is the inverse of this statement true? And the answer is yes. So you have an experiment called as Franklin's experiment, which shows this. It's a simple setup. Let me explain it this way, what the procedure is. So what you do is you take up a flask. Okay, it has a big neck, right? So I'm not going to draw that way. So it has a big neck and something like that. And you fill it with water and then you boil it, right? You basically boil it. So you have the steam and everything. So you, along this, actually somewhere along this point, you close it. So basically what do you have? You have a flask with steam. You have a flask with steam. So to this, what you do is you, of course, stop heating and you arrange, or actually even if you take just what, if you just take cold water, right, and put it on the flask, then what happens? Flask temperature drops, right? It's a simple thing. I took cold water and poured it on that. So obviously that temperature drops. Okay, guys. See, the flask was full of steam actually. You boil it and you have steam. Majority of the things is steam. Flask with steam, and you try to see to that the steam fills the entire thing. The majority of the flask is with steam and there's no water, right? At least not in liquid form. That's what I mean. Sorry. I'm not telling no water. I'm trying to tell that it's not in liquid form. Flask should be filled with steam. Entire flask with steam. Okay, that will be a better statement. Entire flask is with steam. Flask is with steam. So when you put a cold water on the setup, the flask temperature drops. And what happens? Just a second. Yeah. What happens? We see condensation. Is it not, guys? So basically you have your water becoming liquid. So from steam to liquid. So basically steam to liquid. This has a hole. What happens to the pressure inside the flask? It was there everywhere. Now it is occupying less space. So overall the effect is that the pressure drops. Okay, so after some time, what you get to see is this liquid, right? This liquid starts to boil. Literally, the liquid, it starts to boil. Even though there is no source of heat, right? So this is without any source of heat, any external source of heat. External source of heat. It starts to boil. It's weird, is it not? You don't have this setup. You switch this off. You just took cold water and poured on it and it starts boiling. How is that even possible? Because the pressure drops. Because the pressure drops, the boiling point also drops. So even with the external atmospheric temperature, right, room temperature, it starts to boil. Right? This is without any external source of heat. Actually, there is, but not your, this burning kind of thing, not the obvious one. So this happens at room temperature, and this shows that you have water and it can boil below 100 degrees Celsius. Okay, it's the same thing, whatever I explained, just that the setup is a bit different. But yeah, you can read through